here's a fun physics problem for you. We have a 10,000 pound object, so that's giving us a weight. Remember, weight is a vector, is suspended on a wire tied to two poles. The angle between the horizontal and the wire to the shorter pole is 22 degrees. The angle between the horizontal and the wire to the taller pole is 49 degrees. Find the tension in the cable to each pole. Okay, so I'm going to draw my axes where these poles intersect. Okay, not where the poles, where these forces intersect. Right, so what I have going on here is three forces in equilibrium. They're in equilibrium because the weight, the heavy object is not moving, right? So it's just sitting there. It's in equilibrium. There's no like extra forces. It's just holding it still. But we have three different forces happening here. We have the wire to the shorter pole, right, which makes a 22 degree angle here. Okay, so that is, let's call it force 1. Okay, so that the magnitude of force 1 times cosine of the rotation from the positive x-axis is 180 minus 22. So it's cosine of 158, right, which is this rotation, comma, sine of 158. Okay, that is the shorter one, the wire to the shorter pole. And then the wire to the taller pole, it told us that makes a 49 degree angle with the horizontal. Nice thing with how I drew this was that's just the angle, right? That's the rotation from the positive x-axis. It would work if you flipped this, but we're going to give you this diagram in a problem like this. So the long is magnitude of F2 times cosine of 49, sine of 49. Okay. And then our third vector, the third force, is actually gravity acting on this heavy object. Okay, so that is a magnitude of 10,000 acting at an angle of 270. And that's how far we had to rotate for it to go down from the positive x-axis. Now that's ugly. Oh, shoot. Oh, well. Okay. And then again, like I said, these are all in equilibrium. So if I add these together, they need to add to 0, 0. Okay, so I'm going to add the horizontal components and I'm going to add the vertical components. So the horizontal of the short, horizontal of the long, and then horizontal of the weight, but cosine of 270 is just 0, so we actually don't even need that. Okay, so this one becomes equal to 0, and I just eliminated that because there's no horizontal component to weight. So that's horizontal, and then vertical. We do have a vertical component though. So sine of 270 is just -1. So I'm going to use -10,000 for that when I write it out. So this is absolute value, oh my God, not absolute value, magnitude of force 1 times sine of 158 plus magnitude of F2 times sine of 49 minus 10,000. Remember, that's just -1 times 10,000 for the sine of 270 equals 0. Okay, so now what we have is a system of equations, which is kind of a pain to solve, but you can solve it. We would do it in the calculator. So you would just kind of graph these, make this x and this y, and you could solve for x and y by graphing and finding the intersection. Okay, so why don't you try that? I'm not going to actually show that because you can graph lines, but it ends up getting that the one force is 9,806.09 pounds, and then the second force is 6,938.62 pounds. Okay, so again, you can solve it using a system if you like really want, but that's kind of hard. I would just graph both of these in the calculator using X and Y for F1 and F2 because these are really just constants or coefficients, and find the intersection.